The Big Bang Theory is the prevailing scientific explanation for the origin of the universe and the creation of the world as we know it. It is a well-supported cosmological model that describes the rapid expansion of the universe from a singularity, a point of infinite density and temperature, to the vast and ever-expanding cosmos we observe today. Here, I will provide a detailed overview of the Big Bang Theory and how it explains the creation of the universe. Welcome back, fellow space enthusiasts. Today, we're in headfirst into one of the most mind-boggling and awe-inspiring topics in cosmology, the Big Bang Theory. This theory not only explains the origin of our universe but also unravels the story of how everything we know came into existence. So, grab your cosmic thinking caps because we're about to explore the birth of the cosmos. THEBIGBANGTHEORYEXPLAINED. The Big Bang Theory is the leading scientific explanation for the creation of our universe. It all began approximately 13.8 billion years ago when the universe was nothing more than a tiny, hot, and infinitely dense point called a singularity. Yes, we're talking about something so small it's almost beyond comprehension. At this point, all the matter, energy, space, and even time itself were crammed into this incredibly tiny space. Cosmic expansion. Shortly after the singularity, the universe began to expand rapidly. This expansion is not an explosion in the traditional sense, but rather the stretching of space itself. As the universe expanded, it cooled down, allowing particles and atoms to form. Formation of fundamental particles. In the early moments of the universe, only fundamental particles such as quarks, electrons, and photons existed. These particles combined to form protons and neutrons. But then, something incredible happened. The universe started expanding, and it's essential to understand that it was like an explosion from a single point into empty space. Instead, space itself was stretching and carrying everything with it. Nucleosynthesis. These protons and neutrons played a critical role in a process known as nucleosynthesis, where hydrogen and helium nuclei formed. These light elements are the building blocks of stars and galaxies. Fast forward to about 380,000 years after the initial expansion, and the universe had cooled enough for electrons to combine with atomic nuclei, forming atoms. This allowed light to travel freely, making the universe transparent. The afterglow of this moment is what we call the cosmic microwave background, or CMB. Discovered in 1965, the CMB is a faint glow of microwave radiation that permeates the entire universe and provides strong evidence for the Big Bang Theory. But the Big Bang Theory was not always universally accepted. In fact, it was only in the 1960s that the theory's major prediction, cosmic microwave background radiation, was finally discovered, providing undeniable evidence of the Big Bang. Before that, man,